Okay, dig out your notes. Here we go.
I like that you actually clarify, like, wait, no, I meant about this.
All right.
You're talking about what's in
Oh, yeah. I actually didn't
You guys. All right. You know, in Algebra 2, I'm sure you've noticed that since August till now, things have kind of transitioned themselves towards Algebra 2, right? Sometimes review, sometimes not review, you know. But it's been easy, then it gets hard, easy, then hard. Well, here, from about right now, Thanksgiving on, Thanksgiving probably till May, it becomes a lot of new stuff to you. And this is one of the newer things. You were never told about this group of numbers. This group of numbers is known as the complex numbers. Now, your number background is what? What do you guys know?
Real.
The real numbers, that's all you know. The real numbers are any number you can think of. Okay?
Mm-hmm.
But now, starting today, the number system just got bigger. Well, let me show you why. You remember, on your quiz, when you did the quadratic formula or completing the square, and you might have got something like that. This number inside is known as what name again?
Discriminant.
Discriminant. So this number is really called the discriminant. And the discriminant tells you how many solutions, right? 2, 1, or none. What would you say?
0.
None. No, 0. Okay. So you'd say there's no what?
Resolution.
Ah, good job. The word I left out was this. There are no real solutions, right? And the reason I made you say real is because today
That's great.
there are solutions. Today, discriminant will always talk about reals. It won't talk about negatives. But here's what happens today. Today, there are 2 not real. What are they called?
Imaginary.
Yeah, today, starting today, you will get solutions. They're called imaginary.
Why was the word imaginary chosen?
Good question. Now, here's what happened. Just so you know.
5-year-old
If you can go back, 600-700 years ago, if you could somehow look in the past, what happened is this. Mathematicians that were figuring out all this stuff, how does the number system really work? These mathematicians were very frustrated, super frustrated with negative numbers inside radicals. So here's what was going on. They knew the answer to this. What is it?
3.
It's 3.
3. And you know it's 3 because
3 times 3 is 9.
3 times itself is what? 9. This is just a vicious circle. Square root of 9, 3. Square root of 3, 9. It can go around and around forever. Okay, what's this?
You said it wrong.
5.
5. Why?
5 squared is 20.
Because 5 times itself is 25. Okay? Okay, now here's what happened. These mathematicians that are trying to figure out all this sense. How does this all make sense? They were so frustrated with negative numbers. So they said, wait a second. There's got to be an answer to this. There just has to be an answer. So they invented a new number system called the imaginary number system. Now, the square root of -1, they called it
I.
I. They called it I because it's known as the imaginary number I. And what is the imaginary number I? It's equal to what?
-1.
No.
Square root of -1.
There you go. They didn't know what it was, so they said, let's just make it up. Let's call it I. But then they went, wait a minute. Look back here. Why is the answer 3? Because 3 times 3 is 9. Why is the answer 5? Because 5 times 5 is 25. Why is the answer I?
I times I, isn't it?
Because I times I, or I squared is what? -1. So then they realized, wait a second, we made this up. Square root of -1 is I. So that means if I square that number, I should get that number. So then what happened was, now they knew this. They knew that I squared is what?
Square root of -1.
No.
Or
I times I squared is what?
-1.
-1. And the square root of -1 is I. So here are the two things. When you walk out this door, right here, walk out this door in 50 minutes, you've got to know this. Square root of -1 is what? I. Which means I times I has to be what?
-1.
So there's the two things you should know right now. Do you feel comfortable with what I said? Okay. Yes or no?
yeah.
Yeah? Okay, I haven't shown you what to do yet. I'm just saying, square root of -1 is I, and I times I squared is -1. Okay, now, here we go. Let's start. So, we don't know the answer to this, right? There is no real solution. But now that you know square root of -1 is I, you can break this number down into what? Two numbers. Now we always break it down into perfect squares.
3i and
9's perfect. Don't want to change 9.
No.
9 times what is -9?
1.
1.
-1.
So it would be I.
Oh, so now here it comes. What's the square root of -1? I. What's square root of 9?
3.
3. So the answer becomes what?
3i.
3i.
Question.
I had a question for you, but go ahead.
So, like, I understand that I is for imaginary, but is that, what if you get questions with variables that have I in it? How, like, is I still allowed to be
No, you're not going to get questions with I in it. You're going to get questions like this.
Okay.
What's square root of -9? You'll say, wait a second. -9 is -1 times 9. Square root of this, I. Square root of this, 3.
Okay.
The answer is 3i. But now my question is, why? Why is 3i the answer?
Because 3 squared times
No, don't say that.
Because there's no real solution.
Because
You're right.
Because 3
But wait a
squared
second,
times I
3i. You're saying 3i for a reason. John.
3 squared times I squared.
I mean, the square root of 9 is 3, and the square root of -1 is I.
Okay. But guys, when I started you here and said, what's the answer? You're telling me 3i is the answer. Oops. 3i is the answer. Why? How come? Isaac?
And because we continue to cycle.
Yes, and what's the cycle?
-9 squared equals all that in loop.
Yes, I was hoping you could tell me what the loop. You're supposed to be able to say this. Because that number, 3i, times itself, guys, isn't 3i times 3i supposed to be this?
Yeah.
Okay, let's do it. Ready? What's 3 times 3? What's I times I? I squared. But what's I squared?
-1.
And what's -1 times 9?
-9.
Is that what I have in there? It works.
Quick question now.
It works. It's crazy, isn't it? Yeah.
Oh, never mind. I understand.
Okay, all I'm trying to say, you guys, when I asked you this, you told me this. And then I said, why is that the answer? And you said, well,
3 times
because 3 times 3 is 9. It just makes a circle. Well, this is doing the same thing. It's making a circle. What's square root of this? 3i. Why? Because 3i times 3i is -9. And then I'm back here again. I can make the circle forever.
So why would you not be able to do 3 squared times I squared?
3 squared.
Like, instead of writing it as 3i times 3i, could you write it as 3 squared times I squared?
3 squared
Like,
times.
is there yes.
So you're telling me the answer
Times-
is
I
nine.
squared. I squared. Isn't that essentially the same as 3i times 3i?
that would be, yeah, I see what you're saying, but the answer, the answer comes out as this. I don't know where that answer came from.
Oh, okay.
See, to me, I know the square root of 9 is 3. I know the square root of this is I. When I know the square root, I can pull it up. Let's try another one. Let's just try another one. Okay. Square root of, ready?
36. 6i.
-1 times what?
6.
Square root of this.
36.
Square root of this.
I.
6i. Okay? Okay, guys, too much chitter chatter. If you have a question, raise your hand. Okay, so I've made them fairly easy so far because the number inside has always been what?
Perfect square.
Perfect square. So you'd say the answer to this one is?
Negative 1 times 9.
Okay, so you're, okay.
Square root of that.
Negative 1 times, right?
Yeah.
Which is? 9. They've been easy for you because the number inside is perfect.
Yeah.
So when I don't give you perfect like this, they get a little harder. Square root of negative 48. See, some of you on your quiz last week had trouble with this. You didn't know what to do with this. You're supposed to be simplifying. Is there a perfect, is there a perfect square that goes into 48? 9, 4, 9, 16, 25, 36.
That's as far as you can go.
4 does. But you missed one.
1.
Well,
6.
you don't ever try one.
16.
Yeah, 16 is better than 4. So you could say what? Negative 1 times 16 times what? 3. Right? What's the square root of 16?
4.
What's the square root of negative 1? Do you know the square root of 3?
No.
No. So now look how funny your answer looks. Yeah, because, oh yeah. On the quiz? Yeah, so many of you on the quiz were getting the square root of, let's say, 48. You just leave it. It said right on top, simplest radical form. That's not simplest radical form. You have to do this stuff. Of course, last week you never saw the negative 1. It wasn't there last week. It is now.
Did anybody get that right?
Oh, yes. Taylor, you must not have said it right. Try another one. Ready? Try this one right here. Show me the answer when I walk by. Just jot it down.
Grr. Ow, my foot.
Just in your notes.
7.
Did you lose your notes?
No,
Okay, I
Yes.
think I got it. Okay, got it. What is it?
I got it.
Sir, point
Two
at
R
it.
squared. Yay.
Just point at it.
Apparently. No possible way.
Yes.
We're probably for this.
Four's not right.
Making me
Everything else is
worried
good.
because I mean,
Yeah,
that's
sure,
good.
what I can learn this.
Yep.
Yeah.
Got it. Okay. Here we go. Hurry.
Please don't. Yeah,
See, you guys, I hope you understand. When I see negative, I always put negative 1, right? Now, all I concentrate on is 28. What perfect square goes in 28? 4 and 7. Pull this out. 2. Pull this out. I, right?
Mm-hmm.
That you don't know. Leave it in. There it is.
Yeah.
Last week on the quiz, you know what wasn't there?
I.
No, what wasn't there was the negative. So then this wouldn't be there. And then this wouldn't be there. So last week on the quiz, that was the answer. 2 squared is 7. This week, you got a negative. So now you have to put what in there? I. Okay? All right, good enough, right?
Yep.
Let's go back to your notes, and we can fly. I do not have to read this to you because I have been talking about this for the last 5 minutes. Here's where we start right here. What's the square root of negative 2? Okay, ready? You should be thinking negative 1 times what? 2. So they've already given you half the answer. What's in front? I square root of 2. Good?
Yeah.
So what's the square root of negative 3? -1 times 3. So this has already got an I out in front because of the -1. What's inside? Yeah, you don't know the square root of 3. You're done. I square root of 3. Now this one has nothing out there, so you're on your own on this one. Start with -1. Is there a perfect square that goes into 6?
No.
No. So there it is. What's square root of -1?
I.
I. Square root of 6?
Square root of 6.
Don't know. There's the answer. I square root of 6. This one is weird. I would never do this to you. They're giving you the answer and expecting you to go backwards. So inside the radical, there's an 8. Where did the I come from? Which means what's in there? Good.
Oh, that makes more sense.
That's going backwards,
Oh,
and
yeah.
I don't do that to you, just so you know. Yeah.
Then isn't it not done with their answer because you can still simplify 8?
Oh yeah, I get what you're saying. Like if I was starting here and going this way, I'd break up 8 even more. I get you, but they're not asking you to. They're asking you to go
As
this.
long as I wasn't wrong with
No.
thinking that it can still be broken up, we're good.
Yeah, no, you're right. You're right. Okay.
So
Yes,
much.
Adrian. I promise there is, but for right now, you gotta learn the basics.
If it doesn't solve for a number, how's your
Is that what you're
application?
doing?
There's a reason for it. I promise. But you're getting. Now you want to know
Yeah, just,
the reasoning.
I wanna know why I'm learning it.
Well, because.
I just
I'm just looking at the time. Here's why. Because sometimes you want to know the answer to something, and really the answer is just like a parabola, and the parabola can hit in 2 spots. Boom, boom. One of them might be real, and one of them might be imaginary. Well, which one is the one we want?
Real.
The real. This is imaginary. It's not working. This is wrong. This is correct. And if you're out there trying to figure out where something actually hits something, you got to be right on. Can't pick the wrong one.
So it's like about identifying.
Yeah, you're going too far up for me. I got to start you from scratch.
Okay.
Okay, this one. Can't read it? Whoops. Yeah, it's -25. Okay, this one. -7? -50?
Mm-hmm.
Yeah.
Okay, go. I don't think I need to help you. I think you're good now. Try it. They all have to have -1s in it because they're all negative. Do you want to break up the perfect square or should we just leave it?
No, break.
You want to break it up? It's perfect.
Leave it, whatever.
Leave it.
Don't break it up. It's perfect. Leave it.
Oh,
Okay. Ready? So what's the square root of 25?
5.
-1.
I.
Answer?
5.
5i. Is there a perfect square that goes into 7?
No.
No. So you can't do anything. So it's this. Which one do you know? Square root of -1 is what? I. Square root of 7?
Square.
No. I square root of 7. How about 50? Isaac? 25 times 2. Square root of 25.
5.
5. Square root of I.
Well,
I. Well, what did I say?
you just
I-
said square.
Square root of -1. I. You don't know which one. Okay. There you go. Sometimes I'm talking to you guys, and I say the answer because I'm thinking of the answer.
I do that all the time.
Do you do that? Okay. All right. Here we go. Yes, sir. Kelly?
What's the square root of I?
Hush, Sharky.
Square root of I. You couldn't. You'd be asking me what's the square root of -1. So So
Yeah, I was wondering.
I'd have to say the square root of I is the square root of I.
No.
So would work. Okay, ready? Here's what you just learned this. Stay with me. An imaginary number is any number in the form a plus bi. Please stay with me because this next section is all about the form of an imaginary number. So what does imaginary look like? A plus bi, where a and b are real numbers. B can't be 0 though. Because if b were 0,
Can it be 0?
it would be 0i, which is nothing. All you'd have left is what?
A real number.
A. You don't even have an imaginary part. So you can't let b be 0. Imaginary numbers and real numbers together make up the set of
I.
complex numbers. Now, so today, Adrian, quit talking to him. Stay with me. Complex numbers, right here. There's a little diagram here. Please follow the diagram. Complex numbers will always be in this form, a plus bi. But there's two parts to complex numbers. Okay, you guys came into this room today and you knew about that group of numbers called the what numbers?
Real numbers.
The real numbers. But today, complex numbers make up this side, the reals, and that side, the imaginaries. So now, you walked in the room, you knew about these numbers, the reals. Now today, there's what? Imaginary. So together they make up this huge system of numbers called the complex numbers. Okay. Okay. I think you know about real numbers, so let's talk imaginary. Imaginary numbers can be written in this form. A plus what?
B-I.
bi. So what I'm trying to tell you is this. Oh, it's right here. Sorry. It's right here. A plus bi. The A, the number in front, is the real part of the number. The bi is the imaginary part. So, quick example would be like this. 5 plus 3i. That's an imaginary number. Okay? This part right here is called the what? That's the real part. This part right here is called the what? Imaginary part. Okay? Now, here's the deal. This is the real part, this is the imaginary part. If for some reason, if this 5 is gone and it's really just this, that's nothing. So what's really there? 3i. And they say if you have a 0 in front, it's called a what?
Pure imaginary.
It's pure imaginary. There's no real to it. So this one is pure imaginary. Okay? Pure imaginary. This one is not pure because it's got a real part to it. Now, the other thing they say is what if the imaginary part has a 0 for b? So if all you have left is what? Just 5, but no I. All you have is what? You have a real number. So that's a real number. That's pure imaginary, and this is a combo of both. Okay. So now keep following my diagram down. You can graph this. How do you graph imaginary numbers? Well, you graph it by getting points. Where do you get your points from? Right here. A, B. A is the x value. B is the y value. Where do you get the A from? Which one's A?
5.
Okay, 5. Which one's B?
3.
3. And now you graph this. How do you graph it? Well, the x-axis is known as the real axis, okay? The y-axis is known as the what? Imaginary axis. Okay, so how would you graph this? Well, I'll write that over. 5 plus 3. How do you graph it?
Very carefully.
No, just 5.
You just
5 is on the
5 on the x-axis.
Yeah.
3 on the imaginary.
There's 5, and then 3 what?
On the y-axis.
And this is the imaginary. Whoops, this is the imaginary axis. This would be 1 imaginary unit, 2, 3. So you'd go over 5, up 3, and there's your answer.
Just a point.
Just a
don't
point.
line.
And when I say graph the imaginary number, it's just a point.
Okay.
Next, the next thing I'm going to ask you to do is this.
Please don't ask us to graph an imaginary.
What is,
No.
what's the absolute value of 5 plus 3i?
Five
here's the
plus
deal.
3i.
I think some of you forgot. What does this even ask you?
It's just asking where it is on the number
How
line.
far away?
Away from 0.
How far away from 0? Yes, this is 3 away from 0. What's this one?
3.
3 away. So it's always positive, right?
Yeah.
Okay, so here's the deal. Go back here. Where'd it
All
go?
down.
All the way down?
Down.
Okay. What am I asking you to find? How far away from,
0.
where's 0?
X,
Right here.
origin.
Origin. So I'm asking this. How far is this from there to there?
5-3.
5, 3?
Or 5 units is the right. 3
What?
units up.
You would.
Oh, distance formula I'm hearing. Watch
Yeah.
this. Watch this. How far is this?
5.
How far is this?
3i.
Oh, and I'm asking you to find this.
3i.
It's a right triangle.
Theorem. Pythagorean theorem.
Pythagorean theorem. Put your phone away. Shh. Listen. It's the Pythagorean theorem. Right? How would you get this distance? Leg squared
A
plus
plus b squared equals c squared.
equals what?
C squared.
There's c. C squared. Okay. Then to get c all by itself, what would you do? Square root of all this, right?
Yes.
5 plus.
Okay. Here's the deal.
34 squared.
Guys, look over here. Look over here. How can you take a imaginary number and find the absolute value of it? Didn't I just take the a and do what? Square it. Didn't I just take the b, square it, and then took what?
Square root.
Square root. Guess what? Here's the formula.
5 and 3 then.
If you just do this, you will find the absolute value of that imaginary number. There's your formula. Now, where am I getting all this information? It is on the next page of your notes. It's right here. So here they talk about you graphing. They talk about how do you find the absolute value. Here's the formula. It's all right there. Then they say, now, would you please graph and find the absolute value of that imaginary number, 5 minus I. 5 minus I. Okay, equals what point? Okay. Taylor's telling me 5, negative 1. Would you agree?
Oh, yeah.
Real part 5, imaginary number would be the coefficient in front of I, negative 1. Okay, go graph it. Get your spot. Are you about where I am? Okay, that right 5 down 1 would be it. Okay, so on the quiz, that's your first point. Okay, then it says give me the absolute value. Well, the absolute value says how far are you away from what? 0, 0. And you have to understand you're looking at a triangle with legs of what? 5 and negative 1. Oh, I'm looking at a triangle? 5, negative 1? This shouldn't be too hard. What's the absolute value of 5 minus I? Well, here's the formula up here. Leg squared plus leg squared, take the square root of it. So what are we going to put in for A? 5 squared plus, what's your other leg? Negative 1, which ends up being square root of what? Oh, so how far is your point from 0, 0? Square root of 26. What's the square root of 26?
Do
roughly,
we have to find it?
roughly about. Well, I do know square root of 25 is 5. Square root of 26 would be a little bigger than 5. Probably like, is that what it is?
5.09901.
Okay, well, let's leave it like that. 5.09. We'll just cut it off right there. So you're just a little more than 5 units away from the origin. Okay? I got another one. Do it again. Graph this, and then find the absolute value. Go. Graph it, find the absolute value of it, circle it, call it good. Hopefully you can compare to your neighbor and say, did you get this? Or you can ask me as I walk by you.
You're supposed to graph it on the same piece of paper.
Yeah, I just grab it.
Don't you do the absolute?
That's wrong.
Oh, yeah, whoops.
Okay, that's good. Good graph. Now, what's the distance from there to there? That's the formula right there. Yep, you got it. Good job. Anybody have it over here?
I did.
So the next corner down here.
Oh, it's right there. Just do it. It's a
Good.
That's fruity.
Yep, no. Graph it. The A value is -3, the B value is -3. Finger.
That's my juice.
I just want.
It depends on what you're using. Let's see. -3. The real number? You're A. Graph that point. Find the distance. Okay, here we go.
Everything harder for everyone.
That's supposed to be scary.
All right. When graphing, pick out A, B. Okay, Annalise, what's A, what's B?
A is -3, B is -4.
Okay, got it. Okay, and the -3 is left 3, and -4 is about right here. So there, that's your point. The distance from here to here, which is the absolute value. Absolute value is the distance from your point to 0. Well, if you look at it, it's just a triangle. This way, this way. You can see your legs are what?
-3.
Yeah, and you wouldn't know. You guys did that a million times in geometry. So you should be saying the absolute value of this is just equal to a squared plus b squared, right? Square root of it. That's all it is. Inside you have what?
25.
Okay, you have 9 plus 16, which is 25, which is 5. Distance is 5. Good? Okay. Getting close to the end, but then I'm going to strike a deal with you, so hang on. What are we going to do? And? Okay,
Hey,
well guess what? They're both easy, but the one that's harder is subtraction, so be careful. So here we go. How do you add imaginary numbers? I'll just make it really as simple as I can. You just take real parts and do what to them? Add them. Then you take imaginary parts and just what? Add them. So that's about as simple as I can make it for you. Now, where are the real parts in these two numbers?
7 and -3.
So 7, the plus, here's plus. What?
Minus would be -3.
-3. So there's my real plus real. Now add imaginary plus imaginary. What's your imaginary?
2, -2 and 1.
Yeah, -2i
Alright.
plus, here's your plus, I.
That'd just be -1i then.
Okay, let's do this. What's that?
4.
Plus. These two combined make what?
-1i.
-1i or just
-i.
-i. Could I make that even easier or better looking?
1.
4
4
I.
minus i?
Yeah.
Okay. You don't need plus negative I, just say what? 4 minus I. That's a big minus sign. Okay. Now, I will tell you this, difference, subtraction, it's hard. Go get it. Let's see if you can do it. Do it in pencil, because you might do it wrong.
Same thing.
It's the same thing. Subtraction, addition, it's all pretty much the same. It's a little tougher. Same concept.
Nothing ever changes. You did it before, do it again.
I think it does.
There's no surprise. Okay, I'm going to rewrite this a little bigger. Anybody want to tell me the number in front of this grouping symbol?
1.
Positive.
Okay, if I put a 1 there and I ran my 1 through, would it change anything? Nope. Okay. So what's the number in front of this grouping symbol?
Oh,
-1.
Oh.
Isn't that -1?
Yeah.
So if I run this through, makes that -3. Right? And that should make sense, -3. But you know what this says? Minus a -2i. Well, when you run the -1 through, it turns -2i into what? Plus 2i. And now you're back to addition. It's just an addition problem.
Oh.
Real part plus real part makes what? Right here.
So really, when you're subtracting,
Subtraction is really just addition. You just have to run the negative sign through.
I did that.
If you've got grouping symbols with a minus in front, you always distribute the minus sign through. And then you just add later. So what's 1?
I
Take
didn't
away
have it
3.
because of magic.
Okay. What's 5i plus 2i? 7i. Here's my bet. This is my bet. Most of you had this. I bet you most of you had -2. But then you saw 5i minus 2i and wrote 3i.
oh, actually, that's right.
I think some of you probably put a 3i here.
Yes,
Did anybody do 3i?
but I did
Minus
negative.
3i.
1, 2, 3, 4,
I
5.
did negative.
Yeah.
Why negative?
Here's minus.
Come see what I
5i.
did. Please come see
minus-
what I did.
Well, I can see why you put a 3 though, but that's not right.
Because I said that the same way that you did. Over here. So,
Where did the -5 come from?
Right?
because it's right there.
No, it's positive 5i. Inside it's positive. Okay. Now,
Screw it.
guys, here's the deal. Your notes start here tomorrow. But it'd be nice to get multiplication over with. It's not that hard. I'd like to grab 5 more minutes of your time. It's 5 less tomorrow. Can you do it?
Sure.
Yeah?
Let's do tomorrow.
No, let's do it now. Let's do it now. Get over it. No. How's your memory on this? What's this?
-1.
-1. Write this down. When you start multiplying, I squared starts to happen all the time. And if you ever get an I squared, you're really getting what number?
Negative.
-1. And I told you in the beginning, don't forget, I squared equals -1. Okay, your first problem is find the product. Multiply. 7i times 3i. You could think of it like this. Real number times real number, imaginary times imaginary. Just think of it like that. 20 what?
Wouldn't it be
21
I squared.
I squared.
Negative
right?
21.
Now the I squared is what though?
-1.
-1. So this really says 21 times -1. The answer is -21. Okay? And I tried to tell you at the very beginning, you got to remember I squared. I squared is -1. Every time you get an I squared when you multiply, if you just change it to -1, take it times 21, you get -21. Okay?
So you just multiply the numbers on the inside.
Well, you multiply the, what no, sorry,
Like just multiply all the real numbers.
the real numbers times
Negative.
the
Negative.
imaginary times imaginary. Yep.
Okay.
To me, that's just 7 times 3, 21, I times I squared, 21 I squared. All right, what do you notice over here?
Other hand.
It's a binomial times a binomial. What are you gonna do? Oh, I heard it.
Oh yeah.
You gotta do that, yeah. Go, do it. Get ahead of me. See if you can get it before I do it. First times first. 8. What are the outer times the outers? What are these two? 2 times 5i.
Negative 15i.
2 times 5i is 10i. Inside times inside. Negative 3i times 4.
Negative.
-12i.
Negative 12i. And last times last.
-15.
I squared.
Negative 15
I squared.
I squared. I keep trying to tell you these I squared pop up. All right. What's the I squared?
-1.
So negative 15
Change to positive.
times -1 is,
Positive 15.
yep. So now you have 8 plus 10i minus 12i. So where's the real part?
Plus 10i minus 12i.
What? No, the real part.
Oh, sorry.
15 and 8 makes 23.
Sure.
Okay, the imaginary parts are 10i, 10 imaginary numbers, take away 12 imaginary numbers.
-2i.
-2. Imaginary numbers.
That. No.
There it is. Foiled it out, I got 23 minus 2i. The I squared is going to mess you up. It just will. Some of you will forget I squared is -1. Yes.
In a sense of thinking about it, would thinking about I as an imaginary number or like be the same as thinking about if it were like just another letter for a variable, as long as
Yes,
it's not I
yes. I
squared?
mean, here's me thinking, what's x times x? X squared. I
Right.
times I squared.
Right.
Yeah.
Okay.
That's all it is.
Making sure.
And that's all anything ever is. Okay, what's this little 2 mean? What are you going to square?
Same as a 3, yeah. -3.
But everything gets in there.
Everything inside gets multiplied by
Itself.
right? Oh, that still looks like the last problem we did. It's just FOIL it out. Isn't it? Isn't that the same problem we just did? You just have to write it out yourself this time. Okay, foil. Foil, foil, foil. Go, go, go. I'm kind of doing the problem slowly, hoping you're looking up going, yeah, that's what I got too. Last times last is negative 3i times negative 3i is
Positive 9i squared.
9 I squared. Right? Okay. This I squared is negative 1, so this 9 times negative 1 is? There. Cross it out. The real parts, when you add, give you what?
40.
40. The imaginary parts. These two.
Negative 42.
Negative 42i.
Yay.
Right? Oh, you guys are packing up.
Yep.
You didn't see D. Did you see D?
Yeah.
Just combine.
Negative 3i times negative 3i
9.
is
Negative.
what?
Negative 9.
9i squared. But that ends up being negative 9. Right? Yeah.
Yeah.
Quizzes?
Quiz right here. But bells get a ring, so this one's yours pretty good. Let's see any more. You want your score? I can't see it out. You want your score? Come to me. No, it will be a 4. If you want your score, come talk to me.
Math. At this point,
That's what I
math
do.
and math are a little different, and math is the one I'd rather do.
But it's not very legal.
Anybody else?
No, it's not.
Yeah.
Okay.
Yeah, that would be bad.
Okay.
What was it out?
32.
32?
Good?
Thanks.
And nobody else. Oh, shoot. Just close it down.
I don't know where you record. I didn't want to
Oh,
in
how-
case it was recording.
how does that
I don't know
happen?
where to stop it from.
Okay, how's that? Let's go here.